We have myself and Dr. Steve Safferman from Biosystems and Ag Engineering at MSU. So what we're going to do is we'll talk a little bit about our poster here, and then we're going to go and give a tour of the processing system. And it's really not for you to go home and think, oh gosh, we have to install this type of system. It goes back to what more of what Amber was talking about is finding what works for you. And if this helps plant some seeds and start some discussion and some thinking, that's why we do this. It's not to think that in Clinton County we're going to have 100 miles of buffers or anything like that, but start to think about what process might work for your particular farm and for your particular system. When we have cows on our farms, we get more than just milk from them. We get approximately 150 pounds of manure a day, and that's excreted manure. That's not including all of the other water that we add into that, the surface waters, the feed pad waters that we collect. So we have that, and then 87% of that is actually water. And so systems like what Wellers have installed here are starting to think about, well, let's take the water out, so then we're handling just the solids, and the waters then can be used for other uses. Within this manure, we have almost a pound of nitrogen, almost 2/10 of the pounds of phosphorus, and almost or over 2/10 of a pound of potash. The problems with those are all good nutrients, and we think of them as crop nutrients. The problem is, though, that they aren't always in the ratio that you need them for crop production. And so in this type of system where you start to separate out the solids and then taking out the different components as different steps along the way, now you've got them separated out, and you can hopefully apply them or land apply them or process them for other uses, at least for the crop nutrient needs. So why do we separate? Farm expansion could be one. You're adding your dairy farms, but you're not going to add more cash crop. You separate out the manure and the fibers and the nutrients, and then you can either process them or provide them to cash croppers for their use. There is a good deal of environmental protection involved here. We've removed the water. As Amber talked about, then now maybe we can do a little better job of keeping them on the fields, less runoff, and in the root zone for crop production. Some communities are starting to watch the amount of pathogens that are in their waterways. And this particular system here will remove the pathogens. Now that doesn't mean they've gone away, but we've removed them out of the water. There's less likelihood that they're going to get into surface waters. We've put them into the solids, and you have the option of field applying them and making sure that they don't get in the waterways, or if you want to, you could compost them and further clean up the product. There is some monetary savings or potential for monetary savings. Dr. Safferman will discuss that a little bit more. If you're not having to store all of the manure, there's the cost involved with manure storage and manure application. And as you take the water out, there's less manure to apply and less manure to store. We talked about the optimizing use of nutrients as you separated them out. And then we've got an almost clean water coming out of this particular system once it's up and running. And you have multiple uses for that particular water source. You can store it and irrigate it. You can recycle it into this system. You can use it for fresh water. And so there's multiple options for that.
I do want to recognize the Wellers for opening up their dairy farm for us today. And the most important part of this stop will be the tour that they're going to provide, where we can ask them lots of questions about the equipment that they have at their facility. So what I wanted to talk about, though, is the general concept of manure separation. And every farm is different. It depends on the management style of the farm. It depends on the objectives of that farm. But I tried to put it into four basic steps. And the first step is a pre-treatment step. And this has to do with getting that water and manure to separate, because as is, it's very hard to get that water out of there. You can't just put it into a screen or a filter. It won't separate. And there's a couple options that's commonly used. Each of these are commercially available. One is the anaerobic digester, so having that manure circulate for 7 to 15 days to 20 days definitely releases that water. But also there's a chemical physical type system, and that's what we're going to see here, where we can use coagulants and polymers to try to get that separation to occur. So this is kind of our first separation, our coarse separation. We can then go on to the separation of the nutrients. So most of the time we have a kind of a more of a rough separation, and this will actually get rid of most of the phosphorus, because if you look at this graph here, most of our phosphorus is particulate. And so all the particulates will be separated here, and about half the nitrogen, since half the nitrogen is in the particulate form. And this is this process is either going to be an ultrafiltration unit, a belt press, a centrifuge, or a screen. So here at this facility, we're going to see the screens and the belt press. The ultrafiltration is a newer technology. I have a picture of one down here. This is basically 20 or so channels in a pipe, and the water goes through that, and the clean water goes out the sides, and the concentrate material goes through. So if you do treat just with ultrafiltration or screens, you get actually a pathogen-free water. All the pathogens will go out, and you get a reduced nutrient water. So the end point on this water could be irrigation. You probably would still have to look at the nutrient requirements of your crop and agronomically apply that water. So you have a couple options if you decide to go further and want a cleaner product. And one option is to go to ammonia stripping. So we do now still have the dissolved materials in here, including ammonia, and it's actually pretty trivial to strip that out with a two-phase stripper, and we get ammonium sulfate out. We actually dry this to get ammonium sulfate fertilizer. That's one option. We can then go to an RO unit, or we can go directly to the RO unit. And so you're seeing an RO unit right behind me, and this is reverse osmosis. And this is another membrane process, but a lot different. Instead of these channels, this is actually wound, it's spiral wound, and it has a very, very small porosity. Metal salts, all the dissolved nutrients, phosphorus, nitrogen, potassium, all will be removed through this membrane. In fact, this is about as clean as you can get water using any sort of technology except for distillation. In other words, heating up the water and then collecting the stuff that evaporates off. So it's a very, you get a very clean product after this membrane system. But it's very important, if you have a membrane system, that you have a good pre-treatment, because the life of these membranes, the maintenance of that membrane depends on the pre-treatment steps. And so at this particular facility, the membranes will be housed over here, but the membranes are actually back in those boxes behind us. So they'll get ready to install those membranes in the near future. So how much does all this cost? I'm going to exclude the front half and just look at the true nutrient separation. And the cost I've seen from manufacturers is about 2 cents a gallon. So that includes going through ultrafiltration, air stripping, and RO, which is actually surprisingly economical, because if you think about how much it costs to store your water, your manure, and then haul it in your tractor in a tanker, that's about 1 to 3 cents a gallon, or average is 2 cents a gallon. So when Jerry mentioned the potential cost savings, you could actually offset the cost of that hauling, because you can now irrigate this water. This water is actually of quality that it's could be surface discharged. And you can also even use this for cow comfort, for cow cooling, and technically even cow drinking, because it's so clean. So very flexible, a lot of flexibility using this water right on site instead of having to move it to pay for hauling it off site. The other advantage is you do get your nutrients segregated, and theoretically then you could optimize the blend of nutrients for your specific crop needs. And that could have advantages of, again, minimizing the trips on and off the field. So with that, I would like to introduce Josh Weller, who's was involved in designing, building, and now operates this facility. So he's going to lead the tour of the facility and answer questions, and he knows everything about this. So Josh, I want to turn it over to you.
All right, as you can see, the sand, there's a hole that's about 4 foot deeper than the trench over here. The sand will also come up, and the incline augers go up into the sand washers. As with the sand and the fiber that's in the sand will come out, go down the side of the sand washers. The water and the fiber will go into this DT machine over here, and the fiber will be sorted out in a rotary screen. The water will get pumped up into the poly tanks, and the poly tanks will be gravity fed back to the water over here. So the water is going to regurgitate itself back and forth for about 8 hours, and one of these poly tanks will be dumped and fresh water will be added in. That's how we get our fresh water into our system. When that system gets all done, we should be able to pump water over here from there. So we can take over here, when it comes out of the sand washers, you see it kind of just slumps down into the sand washers, or the sand shakers. Sand shakers will de-water the sand, and then we go around the corner, you guys can feel the sand and see how dry or wet it is. It's very clean and dry. Fill the sand and see how it is. It doesn't bite. As you guys can see over here, this is a sand lane. We hope to get 95% of the sand in the sand washers and shaken out. Right now, when a new system gets put in, you're going to have fine sand. There's fine sand in the sand that you guys buy. But the fine sand will land in here, and it'll get carried over here, and we're going to throw it out. So you don't want the fine sand anymore. It plugs up your system, and it doesn't like to work very well. All right, here we have a hole with a bunch of pumps and motors in here. See what I was saying? Where the water comes from the sand lane over there, there's 2 tanks. There's a tank underneath all the equipment over here. There's another tank over here. They're each 14,000 gallon tanks, which these pumps will pump the manure. There's 2 flush pumps. You guys saw the water coming out of the auger channel over there. That water just circulates so the manure stays in there. So there's 2 more pumps that'll go to the slope screens. The slope screens will de-water and get the solids out, and then it'll go into a roll press. Then it'll go down to another roll press. And that squeezes all most of the liquid out of it. Then it'll get carried out to this discharge auger. There's 2 more for the McClanahan screen. They're rotary screens. They circle. They're a lot finer screens than the slope screens. And they get dumped into just one single roll press, and the solids get discharged out. And there's 2 more pumps for the accents. Those are the finest screens that we got. And then that gets discharged in the LWR system. All right, you see we have the RO skid here. This is the final step. The water after the purifier, after the big blue box, we don't want to call that thing, call it purifier, but comes in here. It gets more chemicals mixed in here, and the membranes, which he mentioned earlier, are sitting over there. They will go actually in each PVC pipe, and the water will get treated. And when it's all said and done, when it's supposed to work how it's supposed to work, is you'll be able to drink the water. Cows will be able to drink the water. We'll be able to use misters, but for a startup right now, we're hoping just to get irrigated, so we can just irrigate our fields with it. But our long-term goal is to reuse the water, to drink it, to recycle into our farm, and the barn will be used on its own water. About every hour and a half, he's taking about 15 bucket loads out of the auger over there. It's by that kick out of that barn over there, and he is stacking it. And then all the rainwater, we do catch all the water here on this pad. You can see by that board, there's a hole that takes to that discharge tank, and it does flush into our pond, because we do legal rights. We have to catch all of our water here. So, and you guys are more free. This is the sand that's been sitting outside for a week. You guys can see that, and then there's all the solids that we've accumulated over the last month and a half. And